Hello, you are most welcome. I'm teacher Ivan from Wuuna Educational Services. I welcome you to the third lesson concerning O-level vectors. In this particular lesson, we shall be looking at geometry of vectors, and under this we shall look at addition of vectors. So in the diagram given to us, we have origin O, we have position vector P, and position vector Q. So the displacement PO, that is PO, followed by OQ, gives us displacement PQ. In other words, PQ is given by PO plus OP. So if we are at P and we want to go to Q, we move from P, come back to the origin, and then from origin to Q. And that can be mathematically solved by saying that PQ equals to PO plus OQ. That is how we get PQ. And now, according to our direction, we are supposed to be moving from the origin to position vector P. But in this case, when you say PO, you are reversing the direction, moving from P in opposite direction to O, and therefore this is given by negative OP because we have reversed the direction, plus OQ, which gives us PQ as we start with the positive, that is OQ minus OP. That is how we shall get the displacement PQ. Let us look at examples on that. We have example 1, which says that given that OP is equal to vector P, which is 13, 17, and the OQ equals to vector Q, which is 5, 2. They want us to get the length PQ. So in finding the length PQ, PQ is given by OQ. PQ will be given by OQ minus OP. Or we can derive this by saying that PQ equals to PO plus OQ, but PO is negative, OP plus OQ. When we start with the positive, that is OQ minus PO. That's how we get PQ. And now in the question, we are given OQ, so we substitute. OQ is 5, 2, and the OP is 13, 17, which will give us PQ as 5 minus 13 and 2 minus 17, hence giving us PQ as negative 8, negative 15. But the question is asking for the length PQ. So if we are to get length PQ, that means that we get its modulus, which is given by the square root of x squared plus y squared, hence giving us the square root of negative 8 squared plus negative 15 squared, which gives us the square root of 64 plus 225. So whatever you get will be in units. You can simplify that. So that is how we work out the length of PQ. Let us look at our second example. In the second example, we are given that OA equals to 37 and AB equals to 51, where O is the origin. They want us to find the position vector of B and hence the magnitude of OB. So this is how we shall get the position vector of B. We know that AB is given by AO plus OB. But we can sketch this. We have A, we have B, we have the origin O. So we are supposed to move from O to A and from O to B. So that means that initially the direction is OA. So for us to get AO, we shall be reversing the direction, and therefore we say AB equals to negative of OA because we have reversed to get AO, plus OB, which gives us AB as OB minus OA. Hence, we now substitute for what we are given the question. We are given OA and AB. So we substitute. Where there is AB, we write 5 negative 1 equals to OB minus OA. OA is 37. So minus 37. Then we shall take this one, the other side, so that we get 5 negative 1 plus 37 gives us OB, which gives us 5 and 3 is 8, negative 1 and 7 is 6. That gives us OB. And then the modulus of OB is given by the square root of 8 squared plus 6 squared, which gives us the square root of 100 units, which is 10 units. So that is how we get the position vector of B and the magnitude. Then we also have number 3. In number 3, we are given OP and OQ, where OP and OQ are position vectors of P and Q respectively. So they want us to find the area of OPQ. So OPQ will be a triangle. If we try to sketch this, we shall start with our Cartesian plane, and then P is at 4, 4. So assuming this is 4 and this is 4, so that will be P. And then Q is at 0, 2. So Q will be at 0, 2. So this is Q. And therefore, if we want to get OPQ, we join this, we join that, and we join that. So they want the area of OPQ. So this area can be got by the Helmholtz formula, which says that area equals to the square root of S into S minus A, S minus B, S minus C. That's how we can get where S equals to A plus B plus C over 2. So this can be our A, B, and C. So that means that to get the area of OPQ, we must get the length of OP, length of OQ, and length of PQ. Then we use this formula to get the area. Otherwise, that has been vectors for today. Please don't forget to subscribe and hit the bell.